What is the big blue wheel at CERN? Part 2 of 3.
When two protons collide at such high energies, they have the possibility, based on probabilities set by nature, of rearranging themselves in their properties to create new elementary particles, such as the Higgs boson, which we discovered in 2012. These new particles, if they exist, may live for a tiny fraction of a second in the middle of the Atlas detector before then decaying, rearranging themselves again into other particles that then hit our detector. No, seriously. Particle collisions are not like car collisions. They have different rules. When two particles collide at almost the speed of light, the quantum world takes over, and in the quantum world, the two particles can briefly cease to exist. A new particle is created in their place, which lives a tiny fraction of a second before then decaying into other particles. Imagine a car collision where the two cars vanish upon impact. A bicycle appears in their place, and then that bicycle explodes into two skateboards. At the Large Hadron Collider, what this looks like is a collision that results in a huge mess of particles that fly out into our detectors. So the ATLAS experiment takes a snapshot of this huge mess of particles that emerge from each proton collision, and then my colleagues and I spend weeks and months and years sifting through this data to search for evidence of new particles. Now, particle physics is a marathon, not a sprint. Our goal is to leave no stone unturned, to maximize the possibility that we will discover new particles if they exist. Because of this, in a few years, we're going to drastically crank up the collision rate of the Large Hadron Collider, called the High Luminosity Large Hadron Collider, which will greatly increase the amount of data we've taken and greatly increase our ability to discover new particles. In fact, so far we've only collected about 5% of the total amount of data we will eventually collect over the next couple of decades. If nature has a particle that is not just rare, but extremely rare, waiting for us to discover, we increase our ability to do so with this gargantuan amount of new data. For example, when we collide protons at 40 million times a second for an entire year, we make a few thousand Higgs bosons. The Higgs is rare, but what if the universe has a revolutionary new particle waiting for us to discover, like a dark photon, that only shows up a few dozen times a year? A dark photon could be very rare, and a few dozens not enough to make a discovery. So what do? Just give up? You know me better than that.
No, I can't wait even a millisecond for part 3 and the thrilling conclusion.